So page 92. So solving by method of resolving, getting the resultant by method of resolving. Now the benefit of using method of resolving is that you can use this method for any number of vectors, not just 2. You can actually have 10 vectors and the process is exactly the same thing. And I showed you the model of how to do it. In this particular problem, this is what is actually happening. He is running to the right, down the field. How far? 35 meters. And then turning gently to the right, and he's running 15 meters. And the angle over here is 25 degrees. This is what exactly is happening. So the resultant, by the geometrical drawing method, the resultant is supposed to be here. That is supposed to be the resultant. But we are not using geometric drawing method, right? And the mathematical method we cannot use also because it is not at. And therefore the method of resolving is the best way to go ahead with this thing. So how do you use the method of resolving to answer this particular question? What we do is this. You're going to make an axis. Now what is this direction? This is across the field. And this is down the field, right? That's across and that's down. So what is he doing first? Going across. So what I will do is I'll draw the 2 vectors here, both starting from the origin. So that's the main difference between this method and the other methods. Alright, so first vector is this. How many meters? 34. And where's my second vector? The second vector is here. 15 meters going that way. So I'm going to draw that one. 15 meters going that way. At an angle of? So those are my 2 vectors. And now we have to do the method of resolving. So for the method of resolving, you make another table calling the horizontal one here, and this is the vertical one. So all the horizontal stuff, components will be written here, and all the vertical stuff will be written here, right? And vector. So let's take the first vector, this one. How much of that is horizontal? All 35. So put 35 here. How much of that is vertical?
0.
How much of that is vertical?
0.
0. There's nothing vertical. See, how do you know it? Like this. If it's like this, and if I say how much of this meter stick is actually horizontal, all of it. How much of it is horizontal? Nothing. Nothing. Everything is vertical. But if it's something like this, how much of it is horizontal? This component. How much of it is vertical? This part. You see it now? So in this case, everything is horizontal. So this is 35, that is 0. Now go to the next vector. The next vector, since it is at an angle, you have to be careful there. This next vector has 2 components. This has 2 components. Going from here to here, you need to go this way. That's one component. And then this way, that's the next component. So those are the 2 components. Now, looking at this angle 25 degrees, this component is what? Opposite component or adjacent component? Now, adjacent component is given by what? Cosine. So then this component is 15 cosine 25. Now how much is 15 cosine 25? Do it on the calculator and put it there. How much?
15.6.
And now this part of it is a vertical component. How much is that? That is 15 sine 25. See, it's easy to find the component because all you have to think about is this. Is this the adjacent component or the opposite component? And then just get it. If it is the adjacent component, use cosine. If it is the opposite component, use sine. How much is 15 sine 25?
6.3.
6.3 meters. Now let's go to the table. How much of this vector is horizontal? 13.6 horizontal. See, this is the 15 meters. How much of that is horizontal? This much is horizontal. So 13.6 horizontal. How much of that is vertical? 6.3. Which way? Downward. So what do you do? If it is 6.3 downward, you take it as negative 6.3. And remember that part of it. Because it is 6.3 downward, you have to indicate that minus sign there. Because it is pointing. So what's the difference between that and that? You see? So you have to make a difference clearly. So this component is a downward component. Look at the arrow. So to go from here to here, you have to go horizontally to the right and then go downwards. So down, negative. Is that clear so far? And now what do? You add the two. You literally add the two. 35 and this added together gives you, and this added together gives you. So now we have two components of the resultant. So the resultant has two components, namely the x component and the y component. Now what you do is make a new graph, because I don't want to draw it on that. Make a new graph, and on that new graph, copy these. 48.6 meters horizontally. So imagine you're standing here, and someone says, okay, go 48.6 meters horizontal. So just go like that. And then what are you supposed to do after that? Go down 6.3 meters. So from here, go down 6.3 meters. Finish. You reach there. What is the resultant? The resultant is this, which is easy to find now because it's a 90-degree angle. So the resultant is found out by Pythagorean theorem, square root of 48.6 square plus 6.3 square, and the answer is 49 meters. So you got the displacement. This thing is 49 meters. We found out exactly. And that's not the end of the thing. We have to find out the angle. So to find this angle, we can use a trigonometric ratio. So tan of this angle is opposite over adjacent. So tan of the angle is 6.3 over 48.6. So you get tan of the angle to be a ratio. And then finally find out the angle. You know how to do it, right? You know how to do it. Do it on the calculator. Tell me the answer.
7.3.
Everyone should have a calculator displaying that answer. If you're not doing it, then how can you do it at home or in the test? I'm leading you up to here. So you understand why tan theta is 6.3 over this and not 48.6 over. Tan of that angle is opposite over, and this is the opposite and this is the adjacent, so just work it like that. So first find out how much is 6.3 over 48.6, and then second function tan of that answer. That will get you the angle. Everyone is okay with that? 7.4 degrees. So this angle is 7.4 degrees. So the resultant displacement is 49 meters at 7.4 degrees to the right of downfield. To the right of downfield. Yeah.
How come on the chart you got negative 6.3, but then when you put it in the new graph, you get positive 7?
It's not positive, it's negative still, but I'm marking it with the arrow. Just because it is negative 6.3, I'm putting it downward. Now, if this was a positive 6.3, I'll mark upward. You get it? Then the whole thing changes. Any other questions on this? So the answer is resultant displacement is 49 meters at 7.4 degrees to the right of downfield. This is downfield to the right of downfield. Okay, everyone? Alright, the second question goes like this. A plane travels 2.5 kilometers at an angle of 35 degrees to the ground, then changes the direction and travels 5.2 kilometers at an angle of 22 degrees to the ground. What is the magnitude of the direction of the plane's total displacement? Okay, so the plane goes initially 2.5 kilometers at 35 degree angle. So here goes, that's a ground. At 35 degree angle, the plane is going like this for 2.5 kilometers. And then, so that's 35 degree angle.
Wait, with that 2.5 feels like he's going down towards the ground.
Oh, is it going down?
It's going down. It's going to the ground.
To the ground, okay. 35 meters. No, wait a minute.
No, I'm talking about the 2.5.
No.
To the ground.
No,
Like the 2.5.
It doesn't say that clearly, but you can make it to the ground that way, upward. Now, coming downward doesn't. It can be even downward, but upward, that's all right. But downward, remember there's ground there, so it can come and crash. But as upward, you can actually go any amount. It doesn't say that clearly. To the ground simply means with respect to the ground. So with respect to the ground, it didn't say upward, neither downward. So you can take it upward or downward, doesn't matter. You're going to give your answers to the ground again. Yeah.
Wouldn't the 2.5 be like the distance
Mm-mm.
from the ground?
Travels 2.5 kilometers at that angle. So it is moving that much. And then changes direction and travels 5.2 kilometers at an angle of 22 degrees. Okay? So it changes to 22 degrees. That means it's not going to be going exactly like that. It's going to tilt a little bit. So it's going to go like this. And how much? 5.2 kilometers. And then the angle is? Okay? This is what is happening. Now where is the resultant displacement? The resultant displacement of the plane is here. See, that is the resultant displacement. That's what you're trying to find out. That's what you're trying to find out. But again, we're going to use the method of resolving. Okay? Let's go to the method of resolving. As we did earlier, I'm going to make an axis. And on this, I'm going to make two lines. One is at 35 degree angle, 2.5 kilometers. And the other one I'm going to draw is this one, which is at 22 degrees and it's 5.2 kilometers. So I've drawn the two vectors on it, both starting from the origin. And what do you do next? Make a table. Oops. Make a table. The horizontal component and the vertical component. Take one by one. What is the horizontal component of this 2.5? how much horizontally is it going? This is 2.5. That's the angle 35. This is 2.5 and that is the angle 35. So what is the horizontal part of it? What is this? How much is this? You're going to split it into two components. See, these are the components, this one and this one. So what is this component down here? 2.5 what? Okay, is this component adjacent of 35 or opposite of 35? So then 2.5 cosine 35. And that one will be 2.5 sine 35. And tell me how much is 2.5 cosine 35? That's horizontal part. How much is that? Exactly 2 kilometers. And how much is the vertical part? 1.43. Yes, 1.43 kilometers. Now we go to the next vector. The next vector is this one. It has two components. What are the two components? One is this, and the other is that. How much is that? What is the horizontal component? 5.2? 5.2? What? Completed. 5.2, what is this component? 5.2 cosine. How much is that? 4.8. And this part of it is 5.2. The opposite component, 5.2 sine 22, which is how much? How much? So once you have the two components written down, now that is to be done carefully. Once you do that part of it, so again, this is 2.5 cosine 35. This is 2.5 sine 35. This is 5.2 cosine 22. This is 5.2 sine 22. Clear? Add them up. So you get 6.81 and kilometers, and this one is 3.38 kilometers. Now we have the two components. What we do next is to make a chart. Make a chart, and on this chart, this is your horizontal part of it, the first one, which is 6.81, and that's the next one. Is it positive or negative? So which way do you go? Downward, upward? Upward. So that's 3.38. Now where is the resultant? The resultant is right there. So all you do is this. These are the two vectors given to you. You put them both starting from the origin and then split each one, resolve each one into components, and after resolve them into components, add them up, and you got the horizontal component of the resultant, the vertical component of the resultant, put them there and get the resultant. How much is the resultant? 7.6 kilometers. So in the end, this part is 7.6 kilometers. You got it. So the resultant displacement is 7.6 kilometers. That's not the end of the story. You have to find the angle. How do you find the angle? Scott, tell me this. How do you find the angle? How do you find the angle? You know this is 3.38 and this is 6.81. How do you find the angle? What trigonometric ratio?
Second hand.
Exactly, tangent. So take tangent of theta is equal to 3.38 over 6.81. And then get the ratio, and then get the tan inverse.
26.4.
How much?
26.4.
26.4 degrees with the ground, right? Since I said with the ground, to the ground, so you can just say 26.4 degrees to the ground. This angle is going to be 26.4 degrees to the ground. So you have the answers. 7.6 kilometers and 26.4 degrees to the ground. The other two are going to be your homework. The next two, 3 and 4, will be your homework. Yes.
Two questions. So does it not really matter if you say negative 3.38 or 3.38 when you're squaring?
Say that again.
Does it not really matter if you take negative 3.38?
Yeah, it doesn't matter. Doesn't matter.
And then why is it to the ground?
Because they use the term to the ground. Like they said 35 degrees to the ground, 22 degrees to the ground. So use the same term. Okay? Now, he was asking whether, now this is positive 3.38, in the previous question it was downward. So, when you use Pythagorean theorem, like when you square with a negative sign doesn't make a difference. But remember, when you take the tan, don't take the negative signs here. Just take the numbers, because you're looking at the triangle. Okay, so don't take the negative 6.3 and all that, don't take that. 6.3. Make sense or not? Got it? Yes.
No.
No questions about it? Now what we're going to do next is projectile motion. Now students, some of them consider projectile motion to be tough, but whether it's going to be tough or not depends on how you receive this class, this right now. If you take it properly and understand it as I keep explaining the points, then you should be good. Ask questions and make sure that you're awake. Otherwise, you'll have difficulty throughout. Okay? If you want to come in front, these are all empty. You can come in front. Scott, you want to come in? Yeah. It's free here. All right. What is this projectile motion? Projectile motion is motion in 2 dimensions. Motion in 2 dimensions. Now in the past, you have done problems using equations of motion, right? Have you done equations of motion? Where did you use them? You use them like when a car is going horizontally, right? Or when something is thrown up and down, right? You've done both. So you used equations of motion horizontally and you used equations of motion vertically, correct? Now in this chapter, in projectile motion, what's happening is 2 things are happening at the same time. 2 things are happening at the same time, which is something is moving horizontally and something is moving vertically. Both. When both happen at the same time, that is called 2-dimensional motion. That is called 2-dimensional motion. Okay? I'm just giving an example, not of projectile motion, but a 2-dimensional motion. Here is an example of a 2-dimensional motion. Imagine there is a river. That's a river. And let's say the water is still not moving. The water is not moving. And you're here on this side. And let's say the river is 20 meters wide. The river is 20 meters wide. And if you are swimming with a speed of 1 meter per second, let me see. Use your logic and common sense and physics and tell me this. You're swimming at 1 meter per second. How long will it take for you to get across? 20 seconds, simple. Is everyone okay with that? 20 seconds it takes for you to land there. Now. Come up here. 20 seconds for it to reach all the way here. Now let's say the river is not still. The river is moving. There is a river current. So there is a river current of 2 meters per second. So the river is flowing that way, and you're just blindly swimming across. Like, you just want to swim across blindly. No, here. You want to swim across blindly. Will you land here? Where will you land? Here?
No.
On this side. That's common sense, right? So that's how you. Okay, so the river is flowing this way, and when you swim across, you're not going to land here or there. You're going to be somewhere here, right? So you will be going this way, and you'll end up landing there. Why are you landing over there? It's because the river is taking you. As you swim, the river is taking you. How fast are you actually swimming now? You are swimming at 1 meter per second. So listen, you're moving at 1 meter per second. But the river is taking you 2 meters per second. What is the resultant velocity? Right. What's the resultant velocity? You are moving at 1 meter per second. The river is taking you 2 meters per second.
1.4 meters.
How much?
1.4 meters.
How fast are you moving? 1 meter per second, 2 meters per second. How do you find this resultant? Right? How do you get it? Square root of 5. 1 square plus 2 square radical. Use Pythagorean theorem, 90 degrees here. So do you understand it's 2.236? Good. So you're moving at 2.236 meters per second, faster than your speed and faster than the river also. You're going at 2.236 meters per second. Now let me ask you another question. How long will it take for you to reach there? How long will it take for you to reach there? How long will it take for you to reach there? How much? 20 seconds? 80 seconds? 80. Any other answers? How long will it take for you to reach that point, far away from where you are?
No.
Think. It's time for you to think properly. Huh? 20. You stuck with this answer. That's right. 20 seconds. The same time it takes for you to cross this way. It takes the same time for you to reach there. It takes the same time for you to reach there. Because you are still doing your part. You go 1 meter, the river kind of shifts you 2 meters. You do 1 meter, the river takes you 2 meters. You do 1 meter, the river takes. So the river is taking you sideways. That has nothing to do with your speed. You understand that? You're still moving. As far as you're concerned, the river is not moving. So you keep going forward. But the river is kind of drifting you sideways. So you end up somewhere else. But it takes the same. You understand that? You understand this? So what do you understand from this scenario? When you have two-dimensional motion, what is happening one way is nothing to do with the other way. Another example. There is a truck. Well, the truck is not this. Let me complete it. There is a truck. It's not a truck? Doesn't it look like a truck?
It's a It's flanking up.
Huh? Yeah, looking from the top of the truck. Yeah.
It's more slanted.
No, you're looking from the top.
I know.
Bird's eye view.
It's not like a. Okay.
You're looking from the top of the truck. And let's say the truck is open. It's an open truck. Like you can see through from the top. Okay, now? This is the top of the truck.
Is it a party bus?
And
Like a sunroof.
Yeah.
Party bus, all the lights.
don't worry about the construction of the. Imagine it is a truck. It's got an open thing inside. And you are standing here. You're standing inside the truck. Like imagine this is the truck. This room is a truck. You're standing against the wall here. And let's say the width of this truck is 4 meters. And the width of the truck is 4 meters. Okay? Like this. 1, 2, 3, 4. So it's a wide truck anyway. So 4 meters wide. The truck is 4 meters wide. And you're standing across like this. And let's say you're moving at a speed of 1 meter per second. How long will it take for you to get across to the other side when the truck is not moving? 4 seconds. You get it? Now let's say the truck is moving at 20 meters per second. The truck is moving really fast. Will it make any difference to you to get to the other side? No. It makes no difference to you, right? For you, you're just walking inside the truck. Well, the truck may be going pretty fast, but doesn't matter. You're inside the truck. You're going with the truck. So what will happen is this, from a bird's eye view, what is going to be seen? After 4 seconds, you're going to cross the truck, inside. You will cross to the other side. But after 4 seconds, where is the truck, first of all? 80 meters away. So the truck is far away. Truck is far away. And where are you? You're here. Inside the truck, you're there. So a bird will see you going like this. Okay? The bird will see you going that way. At what speed? What is your speed going to be with respect to the bird's eye? So you are going 1 meter per second. The truck is going 20 meters per second. So what is your resultant speed? What's your resultant speed? Everyone, punch the buttons, get the answer. I don't have to remind you. 1, how much? 1 square plus 20 square root. 20.02 meters per second. Are you faster than the truck? So actually you're traveling faster than the truck. Did you get it? How long will it take for you to move from here to there? The same? 4 seconds. It takes the same 4 seconds for you to reach that corner. So do you see that it is totally independent of each other? Yes? Good. I can quote thousands of examples like this, to make it clear to you as to what is happening. Now what is this? It's a gun. What is this?
Bullet.
Got it right. Yeah, got 50% right. Alright, so this is a gun and a bullet. Now, imagine the gun and the bullet. The gun is held horizontal like this. It's held horizontal. And the bullet is shot. And let's say, for example, this is a faulty gun. It's a faulty gun. So the bullet just falls off. And I shoot the bullet just falls off like that. Okay? You get it? Next time, I load the bullet again. Now this time when I shoot, the bullet goes really fast and lands on Shelbyville Road. It lands on Shelbyville Road. how do you compare the times? Like the time taken for the first one to fall there and the time taken for the second one to go to Selby Road. Which one's reaching earlier? They're the same. You already saw from these examples. What is happening vertically is just by gravity. And what's happening horizontally is just because you pushed it. Because he pushed it, it's going fast. But it is still going down under gravity. So gravity is the one who's taking it down. And what is taking it forward is entirely an independent thing. Do you get it now so far? So if I keep the marker on the table like this and drop it, you saw how long it took to drop? And the second time I throw it like that, you saw how long it took to drop there? Which drops earlier? Same. Same time. Do you understand that part? Good. So in two-dimensional motion, what you should understand is the one-directional motion this way is entirely independent of the other way. So let's go to the projectile motion. Now what is this projectile motion? Watch. If I take this marker and toss it up, it comes straight back, right? Can you work with equations of motion for these kind of problems? You've done many questions, right? So how long it takes for it to come back, you can work it out, right? Good. That is one-dimensional motion. So if I throw it like this, it comes back to my hand. Now watch what's going to happen. I'm walking while I throw it. Now I'm walking and I throw it. For me, it went up and came back. For you, how was it moving? It took off from my hands when it was here, and then it landed when it was here. That motion is called projectile motion, right? So when you toss a football, that's projectile motion. You toss a football, you throw a stone, you throw a baseball, everything is projectile motion. So in a projectile motion, what is happening is there is a horizontal movement and a vertical movement. They are independent of each other. Because if I'm sitting inside a car and if I toss it like this, it's going to come back to me in a certain time, right? Does it matter if the car is moving or not? No. Whether the car is moving or the car is not moving, it's going to take the same time for it to come back to my hands, right? So it does not matter. So the horizontal motion is independent of the vertical motion. Do you understand so far? Good. Now let's go to the projectile motion. There are two kinds of projectile motions. And you need to know both. One is horizontal projection, just like the bullet going off the horizontal ground. That's called horizontal projection. How do you solve horizontal motion projection problems? Now, I don't want you to kind of follow any of those things that the book tells you to do here. They solve it, yes, but don't follow that. Just follow what I'm doing, and it'll be very easy for you. And then you'll start, like, any projectile motion problem can be solved in a very easy manner, and I'll show you what to do, and then you just follow that strictly. Here we go. So let's solve a problem with a horizontal motion problem. Imagine you're standing on top of a building. Imagine you're standing on top of a building, 50 meters tall. The building is 50 meters tall. And what are you doing on the top? You're rolling a bowling ball off the building. Don't ask me why. So you have a bowling ball with you and you're just kind of rolling it off the building at a speed of 10 meters per second, horizontally. So what happens to that bowling ball every moment? Okay? At this point, is it moving horizontally? Is it moving vertically? Not at all, because it's rolling on the ground. So it's not moving vertically, but it's moving horizontally, right? What happens as soon as it takes off from the floor? Is it moving horizontally? What speed? 10 meters per second. Is it moving vertically?
Yes.
Negative.
It's moving vertically?
Falling.
Zero. Yeah, when I drop something, what's the initial velocity? So that's what's happening there. The moment it comes off the floor, it's not started its movement downwards. It will eventually move, but it's not moving yet, right? So there's nothing vertically, nothing. But very soon the acceleration due to gravity is going to start acting on it, and it will start pulling it down. So what happens after a little while? After a little while, it is moving with a little speed downward. But how fast is it going horizontal? That stays unaffected. There's no acceleration horizontally. We are assuming there's no air resistance and stuff like that. Okay? There's no wind resistance and all. So still, what happens after some time? Gravity will still keep acting on it, and it keeps falling. Now it is going faster here. See the arrow? I'm drawing longer arrows here. Called 10 meters per second, still going on. What happens after a little more time? See, it's going faster. And now it's going 10 meters per second horizontally. No change to the horizontal speed. And then even when it lands, it goes really fast. But horizontally, it's moving at. So did you notice something? Horizontal velocity is not affected. It just keeps going at 10 meters per second. Whereas vertically, it is accelerating downward. Right? Yeah.
Will there be instances where it's the opposite? Like vertical is constant and then horizontal is.
Because vertical is affected by gravity, it has to be accelerated. There can be problems where it's already drifting down with a constant speed and there's a wind this way. Yeah, it's possible. It's possible. But anyway, simple projectile motion problems are falling by gravity and drifting sideways because it's just pushed. Now this trajectory that you see here, it's a kind of parabolic path. The path is parabolic. This kind of projection is called horizontal projection. Why is it called horizontal projection? Because?
It's constantly moving.
No, the projection itself is horizontal. Now later on, after this, I'll show you what happens this way. Like, that's a real situation, right? You're not going to project everything horizontally. So if you project something at an angle, then what happens? We'll discuss that. That is angular projection. That's something we can do later. But horizontal projection, so how do we solve these problems? Simple. First thing you should do is make a table. And what are you going to do on the table? Mark it as horizontal and vertical. So in other words, we are splitting this problem into two problems. A horizontal problem and a vertical. And now what you're going to do is, horizontally, what's the acceleration? What's the acceleration? Acceleration? Zero. It's not accelerating at all. It's a constant velocity, right? So acceleration is zero. It is not accelerating. So when acceleration is zero, there's only one equation you can apply. Which equation is that? When acceleration is zero, only one equation comes in.
X equals V I plus VF divided by 2 times time.
No, it is just this.
Good try.
There's no acceleration. No, that will work because VF and VI are the same, so it will come out the same as this. So acceleration is zero, only one equation is applicable, that is the equation. Whereas on this side, acceleration is not zero. What's the acceleration? And then of course all the equations of motion can be applied. Right? Now, what am I asking for? I'm asking for this. Find when and where it will land. Find when it will land and where it will land. I want to know where it's going to land and when it's going to land. So to solve this problem, this is what you do. Write down everything that you know vertically about this problem and horizontally. What's the initial velocity horizontal? How much? 10 meters per second. You know for sure. What's the initial velocity here? 0. Do you understand that? The initial velocity is 0 because initially it has just not started moving yet vertically. What else do you know on this side? What else do you know on that side? You don't know the time. Time is what I'm asking to find out. Final velocity, I don't know. Vertically? Huh? Displacement? Yeah, we know the displacement, right? What is a vertical displacement? See, although we're using the same symbols, I'm calling it vertical initial velocity, horizontal initial velocity, because I'm putting it in the right columns. So what is the displacement? Let me see if you are good at it. It is negative 50. If you don't put the negative sign, it will imply that it's going upward. So, since it is starting from here and landing down here, what is the vertical shift? How much vertical displacement is it undergoing? So, do we have 3 things to start our work? Can you find the time? How do you find the time? You need one equation. Which equation are you going to use? X is equal to VIT plus. Yeah, this is the equation that will help you because there's no final velocity. So I'm going to substitute minus 50 is equal to initial velocity is 0, so that part is gone. And then you have half of negative 9.8 times t squared. So it's negative 50 is equal to negative 4.9 t squared. So what is t? Let me see what we get. How much is t? How much is time? Everyone should work. I don't want someone to just simply copy the stuff. 3.19 seconds. Good. So the time is 3.19 seconds. What you do is divide 50 with 4.9, but that will be t squared, and then square root it. Is everyone getting the answer 3.19 seconds? $50 divided by 4.9, how much is that?
10.2.
Now take square root of that.
104.
Square root of it.
Oh, square root.
What did you do? 50 divided by 4.9?
Yeah, that's right.
And then take square root. That is second function, yeah, and then the answer. Okay? 3.19 seconds. You know what? Time is the only thing that is common to both sides. So if you discover the time here, then transfer the time here. If you discover the time on the right hand side, then bring the time and put it here. If you discover the time on this side first, then take that time and put it on the other side. Do you get it? If you discover the time on this side first, then take the time as a piece of data for the other side. If you discover the time here, then take it to the side.
So on the horizontal one, are you trying to find the displacement?
Yeah. So now what is the displacement horizontal? 10 times 3.19, which is? So we have solved the answer. What did I ask you first? Find when and where it will land. When will it land? After 3.19 seconds, where will it land? 31.9 meters from the bottom of the building. You get it? Easy? All problems are going to be like this. Same style. So what do? Make a picture of the problem itself, make a table, split it into two problems, vertical and horizontal. And sometimes you start working on this side, sometimes you work on that side. Yes?
Did you get the 10 from the 10 meters a second?
Yes.
Okay, I got you.
Oh yeah, this one.
Oh,
Okay? Now let's try another one. Also horizontal projection. What's that? Yeah, it's a plane, it's a bomber. It's flying at It's a bomber flying at 720 kilometers per hour. What do you do first to change this one to meters per second? Divide by 3.6. Just divide by 3.6, you get the answer. How much is that? 200? So we won't use 720 kilometers per hour because we can't use it, because it will mix up with our seconds and stuff like that. So best thing is, change that 720 kilometers per hour to meters per second so we can use it.
Wait,
Now
how
the
much,
question,
how much should we divide by?
3.6. That's a shortcut. Okay? Just divide by 3.6. Yeah, you can do it by multiplying by 1,000 and divide by 3 because it's the same thing. Yes?
Never mind.
Now, write down the question. A bomber flying horizontally at 720 kilometers per hour intends to drop a bomb.
Where?
Intends to drop a bomb on a target.
Just some.
And the target is 1,000 meters away. The target is 1,000 meters away. Question is, at what height should it be flying? At what height should it be flying for this to happen? Like, it wants to drop the bomb, it's flying at that speed. Now you can choose which height to fly. Now, 1,000 meters before the target, it wants to drop the bomb. So from what height should it drop the bomb so that it will hit the target right?
So it's just.
So, here's the problem. The question is to find this. How do you start off? What is the initial velocity here? How much? 200 meters per second. What is the vertical velocity? What's the initial vertical velocity? 0. Do you see that part? What is the displacement here? Oh yes, 1,000. You know that. Right? See, 1,000 meters displacement. And on this side, acceleration is known. But we don't know anything else. We don't know anything else. But can you find the time on this side? Because x is equal to vt. You know x, you know v. Can you find time? Go ahead. 1,000 equals to 200t. What is t? 5 seconds. So what do you do now? As soon as you discover the time on this side, what do? Take it and put it there. So t equals to 5 seconds because the time is common for both sides. Now do we have three things?
yes.
Can you find the height? Can you find that? What equation?
VIT.
Yeah, VIT plus half AT squared. Substitute. VIT, that's 0. Half AT squared minus 4.9 T squared. And time is what? 5. What answer do we get? How much?
-1.32.5.
negative 122.5 meters. Why is the minus sign? Because it's going down, yeah. The bomb is actually going down, that's why the minus sign. So what is the height from which you should drop it? 122.5 meters. Did you get it? This is how we solved projectile motion problems. Your homework, I want you to take serious effort to do it, and I'm putting this video on Rockspace, so if you have difficulties, go back to the video and find out how to do it. Your homework is going to be page 92, the remaining two questions, questions 3 and 4, and page 97, 4 questions. Page 97, 4 questions. And all the 4 questions are on horizontal projection, just like this. Okay? And try to follow this method because it's the easiest way to do things.
So was the question